All footage shown in this video was recorded by KRAIS tool users during actual real maintenance and retubing projects. Before a tube can be removed, the weld connecting the tube to the tube sheet must first be removed. The KRAIS MiniMill 100 is used to machine away the weld material from the tube end and tube sheet. The whole MiniMill family is designed for on-site many machining operations commonly performed during maintenance. Once the weld has been removed, the tube is ready for extraction. Once the welds have been removed, tube extraction can begin. The ACTP is a continuous hydraulic tube pulling system consisting of a hydraulic power unit and interchangeable pulling guns. Depending on tube size and operating conditions, different pulling gun capacities can be used with the same hydraulic unit. During extraction, pulling force is applied directly to the tube. As the load increases, the tube begins to break free from the tube sheets and move through the exchanger. In many cases, the tube can be removed completely in a single operation. The extraction process is influenced by many factors. Corrosion, deposits, tube deformation, and years of service all affect the force required to remove a tube. Some tubes begin moving almost immediately, while others remain strongly bonded to the tube sheet and require higher pulling forces. Large heat exchangers may contain hundreds or even thousands of tubes, making tube extraction one of the most time-consuming stages of a retubing project. Continuous pulling systems are commonly used to maintain a consistent pulling operation and reduce manual handling during large maintenance campaigns. Not every tube behaves in the same way. Tubes weakened by corrosion or wall loss may fracture during extraction. In some cases, the tube breaks free from the first tube sheet, but remains locked in the second. When this happens, additional recovery methods may be required before extraction can be completed. The objective remains the same: complete removal of the existing tube while preserving the tube sheet and preparing the exchanger for installation of new tubes. In some situations, a tube may remain locked in one of the tube sheets after partial extraction. The KRAIS MiniCut 100 is an internal tube cutter built for such cases. When only part of the tube remains inside the exchanger, a dedicated tube puller can be used to remove the remaining section. The HPR 20-1000 is designed for extraction of tube stubs in short tube sections. The puller uses spear-type gripping jaws that engage the inside diameter of the tube and transmit pulling force directly to the remaining tube section. This method is commonly used after a tube has fractured during extraction or after the tube has been intentionally cut. Depending on the situation, the operator may access the tube stub from the opposite side of the exchanger, or work directly on a shortened tube section. Tube stub extraction is a routine part of many retubing projects. Service conditions often result in situations where only part of the tube can be removed during the initial pulling operation. The remaining tube section must then be removed before any further work can proceed. Some tube stubs are removed with relatively little effort, while others remain tightly bonded to the tube sheet due to corrosion products, deposits, or deformation. For this reason, the extraction operation must be carried out with care and with continuous attention to the condition of the tube hole. In some maintenance projects, the tubes are cut before extraction, and the tube sheet is separated from the remaining tubing. Once positioned for maintenance work, only short tube stubs remain in the tube sheet. These tube stubs can then be extracted individually using the HPR 20-1000. The choice of this method depends on exchanger design, site conditions, and the maintenance strategy used for the project. Complete removal of tube stubs is necessary before new tubes can be installed. Once all tube stubs have been removed, the exchanger can move to the next stage of the retubing process. The final stage of the retubing process is tube expansion. Depending on the application, this can be carried out using a range of rolling motors, from the compact KRAIS K20 and the popular push-and-pull K50 to digitally controlled electric drives and robotic tube rolling systems. Here is TES 3000, a digitally controlled tube expanding system.